Matt Korfhage is my real name. Matthew Edward Korfhage.
What's your major?
Electrical and computer engineering.
What makes you qualified to speak about traffic lights?
I designed the very first traffic controller that was deployed in California, and I worked on the research and development that team did to make them faster and more reliable.
Can you explain what a traffic light brain is and how the light knows when to turn green?
Yes. So lots of traffic systems work off of something called a programmable logic controller. So you can think about these as computers that are very fault tolerant, and they're used to control a lot more simple industrial things. In this case, we'd consider a traffic light to be an industrial device. So what they're really doing is you have a sensor that you can get data on, or a timer. So I can either detect that a vehicle is in a spot, or I can also work off of a timer to change the light at a certain rate. And that's what the programmable logic computer that's doing in that electrical cabinet is doing on the internals. And then it'll send out a signal to the lights here inside of the traffic light to change them based off of what phase that the intersection is in.
I like that answer. Thank you. Can you answer that again a little bit more, like explain to a 5-year-old?
Yes. So, Magic Light Box takes in signals from around the area. This could let us know, hey, there's a car here, or hey, time's up, we have to change the light. And then it sends out a message to the traffic light saying, hey, I want you to turn green, or I want you to turn yellow. And it synchronizes all those together so cars can go without smacking into one another.
What kind of helpers does the traffic light system have to understand what's going on in the streets?
So we use a couple of them. We like to call them sensors, and they give us information about what's going on outside of the traffic light controller. So a good example of a sensor that we use would be a transducer, which is a type of pressure plate. So when a car goes up near where the traffic lights are, it'll put weight down on that pressure plate, and that'll tell the controller, oh, there's a car here, and then it'll know whether it needs to change the lights based off of that.
Are those usually above ground or underground?
Those are usually underground. So we'll put the transducer in. They're pretty wide, so they can cover a large surface area because cars are pretty big. And then we'll pave over them with asphalt.
How does the traffic light know how long to stay yellow before turning to red?
So it depends on the speed limit in the area. So if I'm a car and I'm going really, really fast, the highway, 60, 70 miles per hour, I'm going to need a lot of time to slow down safely. And if the light doesn't have a long enough yellow light, then I'm not going to give enough time for the cars to know that they need to stop, and an accident could happen. So a lot of times what we'll do is we'll meet with the city and we'll say, hey, how fast are cars normally going in this area? And then when we install the traffic lights, we'll put them on a timer where the faster the cars are going, the longer that they're going to have to stop and the longer that the yellow light will be.
What happens when the system stops working, like during a power outage?
Good question. So we did try and design these things to have a couple of different routes that we can take if something goes wrong. One of the biggest ones is backup generators. So if we're in like a big city area, like a metropolitan area, we're actually going to have say we have a coal power station somewhere nearby, that's actually going to have a gasoline generator that we can use as auxiliary to back up the power in the traffic light system if something happens. We also have different protocols that'll activate if we lose power and we don't have any auxiliary power available. Like for example, whenever the lights are flashing red, meaning everybody treats that intersection like a stop sign, that is like a backup plan if we lose power to the controller. The other third option that we have access to are batteries. Batteries are really cool because they're really great for if we're working in a rural area where we don't have access to auxiliary generators or power like that. So yeah, it really depends on the area that you would be in that circumstance.
How does the system know when to let an ambulance go first, even if the light is red?
A good way to think about it is we sort of have these, they're like beacons or, hold on a second. I think I could explain this a little bit better with the drawing. Right here. You see that? Is that good?
Yeah.
All right. So we can represent any traffic system as a set of linear nodes going together as a lattice matrix. So if we like to say that this is a collection of intersections, right, we can draw this as a 3x3 block grid that you'd see in a typical metropolitan area. I've got my lattice points here, A and B, for example. And then I've got my nodal inputs, the traffic matrix, which show like these are 300 cars per hour. This is 500 cars per hour, right? I can then represent this as a matrix equation to then know, based off of the weights that are going into these intersections, what is happening in the overall traffic system. So if this is Y, our output going into the traffic system, we describe this with our A matrix plus our B matrix, where we have X as a unit vector, which those are our weights of 300 and 500 respectively. It's just simple. So based on the numbers that are going into these different weights, these lattices, if it goes higher, then I know that there's going to be a fire truck or an ambulance coming through, an emergency vehicle. So based on how high the numbers go up, then I can know, oh, I need to let this ambulance or fire truck through.
How does the traffic light decide when pedestrians need to walk?
Great question. So we have these things called walk signals, right? And we use like crosswalks, right, in order to like mark where pedestrians are supposed to go. And that actually like marks where you're supposed to walk. And then you hit the crosswalk, that will stop the lights so the other cars know not to go.
Does the system ever get confused when there's too much traffic?
Many people have asked that question before, right? And I'd actually like go ahead and do like a full on demo here. This is gonna knock your socks off.
Okay.
This is really gonna knock your socks off. So you can see how these light up, right?
Yeah.
So the electronics that are driving these things literally cannot fail. They're like perfectly designed. That's what we call fault tolerant. So back here, there's lots of really advanced electronics that are going on here. They're very high current capability. There's no chance of a short happening. There's also no chance they could get confused because it's all supposed to be deterministic. The firmware and the software is really robust. See, exactly. I just thought of it turning on and it turned on. That's how fault tolerant it is. So thank you for the question, but they don't make mistakes. It's traffic. Come be a traffic engineer today.